Okay, here we are then. Let's have a look at this investigation that we've done for our grade 10 mocks. I want to spend a bit of time really focusing on where you're awarded marks, because I think it's changed ever so slightly, and it's worth being mindful of this alongside the mark scheme. The first thing you may have noticed, which I have already underlined, is that we're in 50 minutes now, as opposed to 45, which it was previously. But that's fine, let's just crack on. First up then, table of triangle numbers. And okay, we've got T1 is 1, triangle number 2 is 3, triangle number 3 is... Okay, so there's a good pattern here. And hopefully you're spotting the pattern. We're increasing by 1 more than we were previously each time. So we had 3, adding 4, and then adding 5. So in order to get the next one, we would take triangle number 5, which is 15, and we're going to add 6. To give us 21. Now, it might seem like a really obvious and easy calculation. However, when we look at the mark scheme for this, there is a communication mark for writing that addition, 15 plus 6. So you need to make sure you're communicating everything that you're doing throughout the process now. Okay. Let's have a look at part 2 then. The table for subtracting consecutive triangular numbers. Okay, so grab my pointer. Let's have a look. What we've got here is it's giving us the answer for, well, triangle 1 is just 1. That makes sense. You can see that here. Then we've got triangle number 2 minus triangle number 1. So that's 3 minus 1, which gives us this 2. So triangle number 3 minus triangle number 2 is going to be 6 minus 3, which I can do in my head. Showing off now. Now, triangle number 4 minus triangle number 3, we could look at again, 10 minus 6, 4. And it looks like there's a pattern there. In fact, there's such an obvious pattern, I'm just going to fill it in. Right, now we need to finish this table. And what I've got here is triangle number n minus 2 minus triangle number n minus 3. That's a little bit tricky to think about. Okay. So what I might do is I might assign one of my triangle numbers to be Tn. So I might just think about my Tn as being triangle number 6, which I know is 21. But triangle number 6, what I'm looking at, well, if in relation to triangle number 6, n minus 2 would be triangle number 4, and n minus 3 would be triangle number 3. So what I'm looking at is what's going on here in relation to triangle number 6. Well, that was just triangle number 6. So we're making a link from this number to this number. So from the 6 to the 4, that's just going to be n minus 2. Okay, let's try this again for triangle number n minus 1 and n minus 2. So if I choose to use this triangle number 6, what's happening for 5 minus 4, well, that's 5, or relative to 6, it's n minus 1. And if I look at triangle n minus 1, if I relation to 6, triangle number 6 minus triangle number 5, that gives me an n value of 6. 6 is equal to 6, but in this case it's n, so it's just going to be an n in this instance. Okay, and for the marks, you get 1 mark for the 3, 4, and 6, and then another mark for the n minus 1, and n minus 2. Okay, moving on. Complete the table for adding 2 consecutive triangle numbers together. And let's just have a look at this. So what we're adding is, for the first one, 1 plus 3. That equals 4. Okay, then 3 plus 6, that equals 9. Okay, so triangle 4 plus triangle 5, 10 plus 15, I reckon I can do. I missed one, have I? Yeah, I have missed one. Okay, so I'm actually doing here triangle 4 plus triangle 3, 10 plus 6, that makes sense. I think 10 plus 6 is 16. Then triangle 5 plus triangle 4, 5 plus 4 is 15 plus 10, 25. And triangle 6 plus triangle 5, well, that was the 21 that I worked out, plus the 15. 21 plus 15, I can work out as 36. Now, hopefully we're looking at this here and spotting a pattern. And it looks like they are the square numbers. And so relative to n, well, 1 squared is 1, 2 squared is 4, 3 squared is 9. So relative to n, all we're doing is we're squaring that value. So this becomes n squared. Okay, so it's trying to guide us now for question 4 on to looking at the last row in question 2 and then question 3. So the last row in question 2 is this one. Tn minus 1, that's this thing. Well, we worked out that as being an n. Then we've worked out Tn plus Tn minus 1 as being n squared. Okay, so by adding equations 1 and 2 together, show that Tn equals n squared plus n over 2. Right, now we need to think about what's going on. We need to piece this together. All we're doing is we're treating this like simultaneous equations, and we are going to add these two together. It's not the clearest way of demonstrating it, is it? We're going to do an addition of these two things. So what I'm left with, I'm going to just kind of go over to the left-hand side anyway, is 2 lots of the Tn plus a Tn minus 1 minus a Tn minus 1, and that will equal n squared plus n. Now these things cancel out because they're the same value, and we're adding and subtracting that same thing. And then to finish, we need to divide both sides by 2 to leave me with a Tn equals n squared plus n over 2. And there we are, we're done. Okay, for the next step then, we need to think about multiplying the equations 1 and 2 together. So what's that going to leave me with? Well, I'm going to get this Tn minus Tn minus 1, which is going to multiply. So that was this thing here, and it's going to multiply with this thing here, which is Tn plus Tn minus 1. And that's going to be the same as multiplying this and this. Well, that's quite easy. N times n squared. Okay. Now what we've got here is we've got a factorized difference of 2 squares. So we could simplify, and we could, in fact, let's do it. So we get Tn, which is going to be squared, plus Tn minus 1 minus that same thing, Tn minus 1, and I'm going to get a minus Tn minus 1 all squared, and that's going to equal n cubed. As I said, these things go, and we're left with T lots of n squared minus Tn minus 1 squared. That will equal that n value cubed. Now, there is a link, obviously, between Tn's and n's, but we've just got to be mindful when we're dealing with triangle numbers and when we're dealing with which triangle number. And that's going to be the key to unlocking the rest of this investigation. So let's look at this from our numerical example and go back to the context that we're looking at. So if we're squaring a t value, well, let's look here. Let's look back to this table at the top where we started. And I'm going to choose to square T2. Sorry, I've gone the wrong way. T2 here. So T2 squared. Well, that is, we'll have to put that equals to 1. That should be equal to n cubed. Gosh. T2 is 3. So 3 squared minus the one before it. So the one before it was 1, the triangle number 1. 1 squared, and that should equal n cubed. Now what is n? And this is what this question is trying to do for you, is to make you link from tn's to n's. Well, n in this instance was 2. If we look back here, what we're doing, where's my pointer? We look back here, what we're doing is we're taking a t value of n, and so n is this thing. N therefore is this thing here, it's that 2. And so that should be the same as n cubed. That's what we worked out. Let's have a look. What have we got? 9 minus 1 should equal 8. And 8 does indeed equal 8. So we can say yes, that's correct. So that's a numerical example of the result. And as I say, that link between tn's and n's is going to unlock the rest of this paper for you. Okay. Next section then. Question 5 here. Sum of two different triangle numbers sometimes equals another triangle number. When this happens, we have a triangle triple. So for example, if we start with, I'm just reading this out, I know you can read yourselves, but let's just go in detail. Start with triangle number 3, which equals 6. Let's just see that. Okay, triangle number 3 equals 6. Fine. From the table in question 2, I'm going to keep coming back to this table. So this is question 2, obviously. From the table in question 2, okay, T6 minus T5 equals 6. Let's have a look. T6 minus T5 equals 6. Okay. And so that implies that T6 minus T5, if it equals 6, and 6 is the same as this thing, T6 minus T5 will equal T3. Which we can rearrange to get this. And so the triangle triple is then 3, 5, and 6. Now it's quite an interesting one, 3, 5, and 6, because we're dealing with the n values, remember, not the triangle number itself. 3, 5, and 6 are not the triangular numbers, it's a triangle triple, where we've got triangle number 3 plus triangle number 5 equals triangle number 6. So let's go have a go at this process again from what we had. So we're told that triangle number 15, triangle number 5 is 15. Okay. So we're going to try something very similar. So we started previously with this, and we had to get an expression for that 6 in terms of different triangle numbers. But it does tell us that first of all, sum of two different triangle numbers sum is equal to another triangle numbers. Okay, so we need to do the difference. So we need to look at T15, and it's going to be 1 less, just like it was here. So T15 minus T14, that should equal 15, this value here, which implies then T15 minus T14 should equal T5. T5 is the same as 15, so that's all the substitution we've made here. Rearranging, we can say T5 plus T14 equals T15. So the triangle triple is 5, 14, 15. So then part B. In the table, each row is a triangle triple. Use part A and any patterns you notice to complete this. Well, part A, we've just worked out one. This answer is the first thing I'm going to input into it. So we've got 5, 14, and 15. Now, it's leading me to spot patterns and see if things go up in a certain way. Process that I went through when doing this was I would look at the difference. Well, how much do we go up from 5 to 14? How much do we go up from 6 to 15? Is there something here? If I can fill in this stuff, then I could probably continue a pattern going on. But we don't quite have it at this stage. So let's just go back and have a little look. So triangle number 4, well, if this goes up by 9 and I split it into 2, it's probably going to go up by 4 firstly. And I would try this. This is my thought. Is that 9? If it was, it looks like they always go up by 1. So this would be 10. Does that work? Does it make sense? Well, If it does, then 6 would then give me, it would then go up by a little bit more. So instead of going up by 5, it would go up by 6. 21, and then it's going to go up by 7. 27, 28. So that's the pattern that I'm spotting. I don't know how confident I am in that answer at this stage. What I might do is just continue and then check back. But for the sake of this, let's just have a look at the mark scheme and see if there's any clues on kind of how we might have had to piece this together. Okay, so looking at this. Okay, so we filled in the table, and as I've done this, as I've erased that, I've missed out on a communication mark. So I've missed out on the idea of showing the differences or using the method of at least using the method at least once, or last columns are triangle numbers. Okay. So you've got to communicate how you're doing it. It says here that the last columns are actually triangle numbers themselves, which is not something that I pieced together. But what I should have done is included the gap. So what I did was I did 5. You can't see what I'm doing. What I did was 5 up to something, then up to 14. And I'm spotting, well, I've got to make a total of plus 9. If I plus 4 plus 5, that means that would be 9, and that would imply then I'd add 6 to the next one, which would be 20, and then add 7 to the next one, which gives me 27. So that's this column here that I'm referring to. And I need to include and keep that information on the paper in order to get the communication mark. So I suspect there's probably some nicer ways of looking at this, but that's just how it kind of came to me in the pattern that I spotted and put together. Be really interested to hear if there is some other ways of looking at it that you've kind of come across. Okay, so we turn the page, and question 6. I must say this took me some time. This is referring to question 2, and it clearly says it, and it's bold as well to draw your attention to it. But I was looking at this table here on the previous page for so long, not making any sense. Good lesson that you can take away from this is make sure you are reading really carefully what it's talking about, and it's trying to obviously communicate something to you, so make sure that you don't miss out on that. Okay, so if we do go back to question 2, and we add the last 2 rows, let's have a look at what they're talking about. So what the last 2 rows are, just get rid of this. Well, it's these 2. So what we're talking about is adding these last 2 rows. And if we were to add them together, let's just see what it says. You get an expression for this thing. Give this expression in the simplest form. Well, let's just check as we go. So we get, it's not easy for me to go back and forth on this. Tn minus 1 minus Tn minus 2. So I've got Tn minus 1 minus Tn minus 2. Hang on, it says, yeah, we are adding them, so it doesn't matter about the order. And then so that was this one here, I need to then add on this one, wrong way, plus Tn minus 1, and that will equal, well, that will equal these 2 things added together. That's a little bit easier. N plus n minus 1. N plus n minus 1. So what have I got here? Well, I've got a Tn minus 1, which is going to cancel with that subtraction of Tn minus 1. And I'm left with, oops, this left-hand side being Tn minus 2. And that equals 2n's minus 1. So that's my answer here. And it's nice just to check that this left hand side here is the same as what we were expecting, and it is. So that's quite reassuring that that's kind of worked for me. Okay, find n when Tn minus 2 is equal to 15. Well, that's going to be when this thing here that we've just established, just pieced together, this 2n minus 1, when that equals 15. That's going to be quite an easy thing for me to solve. So I need 2n minus 1 to equal 15. And that's going to be obviously when 2n equals 16, which is when n equals 8. Okay. T5 is 15. Use your answer in part 1 to find a triangle triple where the smallest number is 5 and the difference between the other two numbers is 2. Now again, we're not actually finding the triangle numbers, we're finding the values for n. And that's quite obvious from the fact that we're given a 5 here. I think that's a good clue, because obviously if we look again at our original triangle numbers, there's no 5 there. So we're looking for a triangle triple, and the value of T5 here is 15. So let me just refer to my scribbles that I've put down already. So this is when n is equal to 8. So we've already done this, the subtraction between them. We've got a triangle number minus the one before it, and that happens when n is 8, which means the n minus 2 value will equal 6, and that's what we've got, 5, 6, and 8. So another way of writing that down is triangle number 8 minus triangle number 6, that equals 15, and it's a rearrangement of that, just like before. And the other way of writing it is the triangle numbers themselves, which is 36 minus 21, that equals triangle number 5, which is that 15. So yeah, rearrangements of that, and we should arrive at the 5, 6, and 8. Okay, we're getting there. We're nearly at the end. What have we got next? By adding the rows in the table in question 2, I'm not going to be caught out by that again. Sneaky. Question 2, show that Tn minus Tn minus 3 is equal to 3n minus 3. Okay, so if I just recall what happened previously, what I was doing was I was adding these two rows with arrows, and that led me to Tn minus 2, these two things. Now if I add this one as well, you can kind of see this is going to cancel with this, and I'm just going to end up with these two things. So actually what I need to add together are these 3 final columns, 3 final rows, they're not columns, are they? And so just to streamline the process, I may just erase wise. I'm gonna, oh, well, it's a show that, isn't it? Okay, so I better write quite a bit of information. N plus n minus 1 plus n minus 2. N minus 1 plus n minus 2. That equals 3n minus 3. And I wonder if that's going to be enough. Let's just refer once again to... Oh, I haven't got the mark scheme open. I just had to teach a lesson, which doesn't help. So I should have it on my review. I think I can open the recent CIM mock paper 6. Should be coming now. Okay, so let's just refer to this mark scheme. Just double check what's adding the last 3 rows. Yeah, so that's all we needed to do for the 1 mark there. Okay, nice. What have we got next then? T14 is equal to 105. Use part A to find a triangle triple where the smallest number is 14 and the difference between the other 2 numbers is 3. Okay, so here we're going to have our thing that we've just worked out, 3n minus 3, and that's going to have to equal 105. So 3n would equal 108, and n therefore equals, it does go, doesn't it? Oh, it's right there. It's right there. 36. I'm looking down at my iPad, not looking at the mark scheme. So we've got the n value of 36, and obviously then The number before that, the t n minus 3, will equal just 36 minus 3, which is 33. So we get 1433, that's not 33, 1433 and 36 for that one. And yep, there's not much more that we need to include. Obviously this communication mark, I can't see how you're going to do it any other way. We're piecing it together and using the tools that's been given to us. Okay, looking back again, or looking forwards, sorry, back at the paper. Find all the triangle triples where the smallest number is 14. Okay. So what we're going to do is, for this, is we're going to look to piece together all of these, this idea of these n values and adding these rows that are possible. So what we've done is we've gone through a process of adding these 2 rows, and we've gone through a process of adding these 3 rows. And we need to think about kind of how that's building up over time. Now, the one we haven't really talked about too much, I suppose, is the n, but we've got the option of adding the 1, 2, and 3 rows, and that's going to be my starting point. So I wanted to see if it's possible for the first row, and well, that's where just n is equal to 105. We also want to know the possibility of those final 2 rows, which is where 2n minus 1 equals 105. Is it possible for 3n minus 3, that was the final 3 rows, to equal 105? Now, how is it building up? We might need to just do one more and just think about what this is going to be. Well, this would be an n minus 3 if we were to build it up. So if I were to add all 4 of those, that would be 4n minus 6, right? Hopefully you can see we've got 1, 2, 3, 4 n's, minus 3, minus 2, and minus 1 makes minus 6. So the next option is for 4n minus 6 to equal 105. Now there's a pattern going on here, and we can kind of keep going with this. I might just see what happens. Well, if n was to equal 105, then we would have 105 and the one below it. Remember, it is how we started, isn't it? So we looked here at using this idea for this, and we used the n value. We found n, and it was just the previous one to it. So the sum of the 2 different consecutive ones. So that would give us 105 and 104. Here we had 2 apart. Now if I solve this, I get 106, which I can divide by 2. 106 is 53. So I get 53 and the 2 below it, because it's 2n, 51. Now 3n minus 3 I've done. I did it here. 3n minus 3, I can just copy that across. That was with 33 and 36. Although I would get 36 first if I'm writing it like this, and 33. So what happens with 4n minus 6? Well, I need to then take my 105. Oh, you couldn't see any of that. So what I was just saying previously, I won't edit the video, was I have done this already. You see here, the 3n minus 3 is equal to 105. That's this one, and I've already got that answer, so I just copied it across. Next, I'm looking for the 4n minus 6. So I'm going to take my 105, let's move this across so that we can see what's going on. 105 plus 6, 111. Now you can see what's going to happen when I try and divide by 4, it's not going to work. So that doesn't work, no answer. Now let's just have a look at what's happening. I'm then going to have 5n. Now what's it going to minus? I wonder. 136. There's a triangle number within triangle numbers, isn't there? So now we're looking at 10. Is that possible? 5n minus 10. Can that equal 105? What do I get? looks like it is going to work, doesn't it? So 105, 10, 115, divided by 5, I get an answer of 23. And I want to then go 5 below that, which is 18. Let's keep the pattern going. 6n minus, after we've added 4, we need to add another 5. 15, can that equal 105? Now that's going to imply that we get 105 plus 15, so 120, divided by 6, which is going to give me an answer of 20. And I want 6 below that, because it's 6n, so that's 14. Next one, 7n minus 21, can that equal 105? Can I get some solutions for that? 105 plus 21, 126. If I divide that by 7, I can get 18. Nice. So we get 18 and 7 less than 18, which is 11. Now, actually, I probably should have stopped already. I need to reject these. So we're looking for triangle triples where the smallest number is 14, and I've got 14 twice here. So obviously that's not going to work. And here 11 is less than 14. So my answers that I'm looking for, and it did say really, it was hidden somewhere earlier that we had to write it in size order, so 5, 14, 15 like this. I can't quite see that. You might be able to spot it for me. So if I find my answers, they are 5, 104 and 105 from the first line. They are 5, 51 and 53. Sorry, it's not 5. I don't know why I've written 5. I think that's just from across. Okay. The smallest number is 14 in all of these. 14, 14, 14, and what are these ones here? 33 and 36. 14 and 18 and 23 are my answers for this. Let's refer back to the mark scheme. So 2 correct linear equations solved for a correct n other than 3n minus 3, because we did that in the previous question. It gets 2 communication marks. You get 1 for writing any one of them down and getting an n value, and then 3 answer marks for writing out 3 triples, really, because obviously one was given to us, or one we've already worked out, for writing out these 3, which you can't see what I'm doing, I've just ticked them, for writing out these 3 as we get there. And that is it before we move on to the modelling. So that's the investigation done.